How big is the universe? Everywhere you look, there are stars. These are in our galaxy, the Milky Way. Light takes 100,000 years to cross our galaxy. If the whole of our solar system, including the vast bubble of comets surrounding us, was the size of a toilet cubicle, the Milky Way would span the distance from Greenwich to Maidstone. Beyond the stars are even more star cities, galaxies of different shapes, colours, sizes, stretching out across space for billions of light years. The closest big galaxy to us is Andromeda. If we sent a text message out to aliens in Andromeda, it would take 2.5 million years to reach them. When we look at galaxies through our telescopes, their light might have taken millions or billions of years to reach us, by which point they would have aged and they might not even exist anymore. It's as if we're trapped on a desert island. We experience a horizon in all directions beyond which we can't see anything. However, our cosmic horizon is receding all the time as light eventually reaches us from farther and farther galaxies. This is like waiting for photos to be delivered to us from distant parts of the Earth whilst on our desert island. Unlike our earthly ships, light travels at a whopping speed of 300 million metres per second. But even light takes a finite amount of time to reach us, and this sets our current cosmic horizon. What can we actually see with our telescopes? Well, we can't see light from the birth of the universe. The early universe was a very hot, small, dense place where light continuously bumped into matter. About 380,000 years after the Big Bang, the universe was large enough and cool enough for atoms to form and for light to travel freely through space. This includes the ancient radiation from the Big Bang, which we can see in all directions. After about 200 million years, the first stars formed, and then galaxies, and then eventually the Milky Way, including our solar system. If the lifetime of the universe was a 10-hour movie, humans would only appear in the last second of the film. Remember, during all this time, the universe has been continuously growing over a period of 13.8 billion years. That's 3 times the age of our solar system. So does this mean that the universe is 13.8 billion light years big? The answer is no. When light first left a faraway galaxy, it was much closer to us, but over time, the universe has expanded like a huge balloon. So the light has taken longer to reach us. Over large enough distances, space can expand faster than the speed of light. This means that signals sent from one galaxy to another would never reach their destination, forever beyond contact. Imagine the universe is a stretchy sheet. If we pull it in all directions, we can find out how much it's stretched by if we know the original size. To explain the current size of the universe, scientists think space rapidly inflated just after the Big Bang. It continued to expand at a much slower rate, slowing down further due to the gravitational pull of new young galaxies. We can calculate the real size of the universe by taking into account all of the matter and the energy present and its current rate of expansion, and another mysterious component. We've seen that very distant exploding stars called supernovae are dimmer than expected, and this tells us that the universe is bigger than we thought, and it's getting bigger at an ever-increasing rate. So, what's causing this anti-gravity effect? The exotic, mysterious component of our universe that cosmologists have introduced is called dark energy, which acts as a gravity repellent. Gravity is still fighting strong and holding together galaxies, stars, and planets. Over large scales, however, dark energy wins, pushing everything out and away from everything else until eventually starbirth will become impossible. So based on all the information we currently have, the proper size of the universe is 93 billion light years across, or 884 billion trillion kilometres, or if our solar system was the size of a toilet cubicle, it would span the distance from Earth all the way out to Venus. Pretty big, eh?